Hello everybody, and following on from the last video, we're going to delve a little deeper into the binomial equation and show how it's derived. So here's the binomial equation that we introduced in the last video, and we want to find out how it's derived. So imagine we have 5 dice, or we roll one dice 5 times, it's the same thing. We want to find out the probability that we roll 4 sixes. So big X is rolling a 6. Little x is the number of sixes rolled, so it's going to be 4, and then is going to be 5 because it's the number of trials or experiments. Now a binomial distribution can also be represented by a tree diagram, where here we have success is rolling a 6 and the failure is not a 6. We can then write 5 letters to represent each of the different outcomes. For instance, the top outcome is 5 S's for 5 successes because you've had 5 sixes. The next outcome is 4 S's and an F because you've had 4 successes, 4 sixes, and then you've rolled another number, so that's a failure. So we'll fill the rest of them in quickly, and then we'll write on a couple of the branches of the tree diagram the probability of success, which is 1/6, and the probability of failure, which is 5/6. Now we are looking for 4 successes or 4 sixes, which are here underlined, and I'm going to write them here a bit more clearly. Now if we look at the top line to start with, we know there is a 6th possibility of throwing a 6, and we have 4 of them. And then for the last throw, there's a 5 in 6 possibility of getting a number that is not a 6. Now we could also write this as 1/6 to the power 4 times by 5/6 to the power 1. Now if we carry on writing this out for all the subsequent lines, we'll see that they're all the same. So the probability of getting 4 sixes is the sum of these lines, which is 5 times by 1/6 to the power 4 times by 5/6 to the power 1. If we write that over here where there's a bit more space, and then we'll go through each bit in turn. So let's start with the 5. Now the 5 is the same as saying we have 5 items and we want to choose 4 of them. And I hope you remember from the combinatorics videos that 5 choose 4 is equal to 5. Next we have 1/6 to the power 4. Well, we know that 1/6 is the probability of rolling a 6. So let's call P the probability of rolling a 6. So we now have P to the power 4. Next is 5/6 to the power 1. Well, 5/6 is the probability of rolling any other number, so it's 1 minus the probability of rolling a 6. So it's 1 minus P, and the power 1 is the same as 5 minus 4, the number of trials minus the number of sixes rolled. So next we're going to swap the symbols in to make it more generic. So 5 choose 4 becomes n choose x because it's the number of trials choose the number of sixes rolled. P to the power 4 becomes p to the power x because x is equal to 4, the number of sixes rolled. And 1 minus p to the power 5 take 4 becomes 1 minus p to the n take x because n is 5, the number of trials, and x is 4, the number of sixes rolled. And remembering that NCX can be written n over x in brackets like this, we can substitute that back into the equation. So the final equation is this, the binomial formula. Now, keeping the tree diagram there for a minute, we know that all the probabilities of all the different outcomes have to add up to 1. Now, if we want 5 successes from 5 throws, that's 5 choose 5, which is equal to 1. And as you can see, there's one outcome where we have 5 successes. Now, if we want 4 successes from 5 throws, that's 5 choose 4. And as we worked out previously, there are 5 different ways in which that can happen. For 3 successes, 5 choose 3, we get 10 different ways in which that can happen. For 2 successes, 5 choose 2, there's also 10 different ways. For 1 success, there are 5 possibilities. And for no successes, there's only 1 possibility. Now you can use the binomial formula to work out the probability of each of these scenarios. I've put the equations down here, but I do encourage you to pause the video and work them out as well. When we've calculated them all out, we should end up with these numbers. And hopefully, if you've done the same, you will find that they all add up to 1. Now, if we were to plot these values on a bar chart, we'd get a chart that looks something like this. As you can see, because we have a very small trial size, we only have 5 trials, we haven't got the greatest looking curve. So I wanted to show you what it would look like if we had 20 trials. And as you can see in this bar chart, there's a very clearly defined single peak. And as the number of successes goes from 13 to 20, the chart is practically 0, because throwing 13 or 20 sixes out of 20 throws is extremely unlikely. You can also see that the chart is asymmetrical because the probability of a failure is a lot higher than the probability of a success. We have 5 chances of failure but only 1 of success. Now, if this chart was for tossing a coin, it would be symmetrical because you have the same probability of a head or a tail. And as always, thanks very much for watching. If you could please hit the like button, I'd really appreciate it. See you in the next video.